Okay, so in this video what we're doing is we're doing something similar to the previous video. We're going to attempt to find a polynomial that fits this table. However, there's a subtle nuance that makes this problem slightly different. In particular, we're looking for a non-constant polynomial that will fit this table. So our instinct says, all right, well, let's do what we did in the previous video, which was use the calculator. So first thing we need to do is hit Stat, go to Edit. And our inputs go in L1, our outputs go in L2, which I've already done. If you haven't done that, go ahead and do so now. And based on this, remember in the previous video we discussed that if we use the calculator and we're using the regression method, then at most, regression-wise, what we can do is if we have 2 points, then we need to use a linear regression because degree 1. Okay? So let's try that. When I hit Stat, we just go over to the calc menu and we need to use option 4 for linear regression. So I get my model for a linear polynomial, y equals ax plus b, and we're told that a is 0 and b is 0. And so my polynomial ends up being y equals 0, which is a constant polynomial, and I can verify that by graphing it. Go to y equals, just type it in. I've already done that. And go to our table. What you see here is no matter what x I put in for my input values, my output values, or the y's, are constant. They're always 0. Our problem asks for a non-constant polynomial, so we need to think a little bit. Well, if you remember back to previous classes, you know that a polynomial has a root or a 0 or an x-intercept anytime the y value is 0. So this particular polynomial has 2 roots or 2 x-intercepts. So the first one is at 1, 0. The second one is at 3, 0. Well, that's exactly what the table told us. But what this means is I have 2 roots. So root 1 is x equals 1. And root 2 is x equals 3. Now, as we'll discuss in a later video in this series, any polynomial can be rewritten as y equals a times the product of its factors. And its factors are just simply its inputs minus the roots. This particular polynomial has 2 roots. So it can be a, which is just a scaling factor, minus its factor. So x minus root 1, x minus root 2. So what I'm going to do is just plug in now. So y equals a, x minus 1, and x minus 3. Okay? Now, here, my scaling factor can be anything that I want it to be. Okay, so it's just how wide or how narrow this graph is going to come out to be. So I'm just going to elect to say that a is 1. So my polynomial for this particular thing is going to be x minus 1, x minus 3. And so this polynomial is a quadratic. I can graph this as long as it hits these 2 points. I found a polynomial that works. So let's go through it. So I'm going to go to y equals. Just type it in y1. So x minus 1 and x minus 3. And then graph. Okay, that looks pretty good, but let's go to our table and verify that we do match these tables. So if I go to x is 1, my y value or my output is 0, that's good. And if I go to x equals 3, my y value or my output is 0. Now, like I just said, I elected for my scale factor to be 1. Well, the scale factor again can be anything. So if I chose for my scale factor to be 3, then my polynomial would just become y equals 3, x minus 1, x minus 3. So let's go and graph that and just see how it compares. So I'm going to type this one in y2 just to compare. So x minus 1, x minus 3, okay, and graph. Notice that the graph is now narrower, so that scale factor affected it. And I'm going to go to my table and verify that I have everything. So when my input is 1, my output is 0, that's good. When my input is 3, my output is 0, so that's exactly what I need to happen, and that's it for this video.